Okay, ladies and gentlemen, welcome to your first notes of Unit 2. So to start off with, we're going to do a little warm-up, and really what we're doing today is stuff that you've always been doing. You know what you're doing on these. So we're just going to start by graphing these two lines located here. All right, so y equals 3x minus 5. Well, we know the minus 5 part is where we're crossing the y-axis. So the y-axis is the up and down one. We're going down 5. Our slope is a positive 3 or 3 over 1 if we want to look at it as a fraction. So we're going up 1, 2, 3 over 1. Now that I have 2 points, I can make a line. Now, let's take a look at this second one. Okay, well, in order for us to graph it, we need it in slope-intercept form. So I'm going to take this x plus 2y is equal to 4, and I'm going to solve it for y. So I'm going to subtract x from both sides. That gives me the opposite of x plus 4. Then I'm going to divide both sides by 2. And I get y is equal to negative 1 over 2x plus 2. So now I'm going to cross the y-axis at 2. Then I'm going down 1 over 2. Down 1 over 2. Connect that line. So I want you to take a second, pause the video, write down things that you notice about those two lines. Once you're done, unpause the video and go ahead and move on. Okay, so on that other video, you probably noticed that the lines crossed once. Okay, they crossed each other. They're not going to cross each other again because they're straight lines, so they're going to keep going on forever after the point that they crossed. So what I want you to do is I want you to graph this set right here. All right, so the first one's easy. It's already in slope-intercept form. This one right here, I'm going to have you put into slope-intercept form. Then I want you to graph those two lines. And again, write down things that you notice. Once you're done, go ahead and move on with the video. All right, so let's talk about systems of linear equations. What is a system of linear equations? Well, first of all, a system of linear equations is a couple of things. So the solution to the system is the point x, y, where the two lines crosses. So if I give you a solution, I say what, or if I give you a system and I ask you what the solution is, you're going to look at where those two lines cross, and it should be a point x, y. Next, the solution of 2, 3 means that the two lines cross at that point on the graph. Now, this isn't the most accurate way of finding a solution, but it is effective for what we're doing right now. So that's basically all we're doing today. We're graphing lines and we're seeing where they intersect. So there are 3 types of solutions that we can get when we're graphing systems of equations. First one, pretty straightforward. That's one solution. Okay, they're crossing one time. And for example, on the graph given, that solution is 4, 1. So if at any point you need to pause the video to write it down, feel free. Next, if we have two parallel lines, they're parallel because they're never going to cross each other. They're going to keep going on separate from each other. They're never going to cross. So that means that we have no solutions. If your line is parallel, you have no solution. Sometimes when we put things from standard form into slope-intercept, we notice that we have the exact same line. So we only graph one line. That's what should have happened on number 2 on your note sheet. All right, so if you have the same lines, then you have infinitely many solutions because they will always be going in the same direction because they're the same line. So here are our steps when we're graphing systems of equations. The first step is just to graph the first line. The second step is to graph the second line. And then the next thing to do is just to find out the ordered pair where they're going to intersect. If they're parallel, then you have no solution. If they're the same line, then you have infinitely many solutions. If they cross once, you have one solution. Okay, you have a little box at the top of the next page. That's where I want you to put this sentence right here. It is as simple as graphing each equation, then finding the point where they cross. That's all it is. You're just graphing the two equations, figuring out where they cross. So let's graph these two right here. So I notice that y is equal to negative x plus 8. So I'm going to go up 8 on my y-axis, and then my slope is negative 1 or negative 1 over 1. Which means I'm going down 1 over 1, down 1 over 1. So I can go ahead and I can graph that line. Next, let's take a look at this next one. Our slope is 4 over 1 and our y-intercept is negative 7. So we're going to take the y-axis and we're going to go down 7. And then I'm going to go up 1, 2, 3, 4 over 1. Alright, now here's the thing with graphing. Your graph is probably going to look a little bit different than mine. It really depends on how straight you're able to draw your line. So this is kind of a guesstimate. It's an estimate of where they're actually meeting. So I would say if I had to pick a point, I'd maybe say like 3.54. That would be the estimate. Well, they got 3.5, so I was close. Okay, again, this is not an exact way of finding the solution. It can just get us in the general region of the solution. Okay, so let's take a look at this next one. I'm going to have you guys actually graph it, but I'm going to start and I'm going to put this second one into slope-intercept form for you. So subtract 2x from both sides, and then you get 4y is equal to negative 2x plus 4. Now I'm going to divide everything by 4. Then I get negative 1/2 x plus 1. Here's what I want you to take note of. Notice that these two slopes are the same. They both have negative 1/2. Because they both have the same slope, they will be parallel. If you don't believe me, I want you to go ahead and graph that one. Okay, so they're both going to be parallel, so you would have no solution on this one. But go ahead and graph it on your graph just to make sure that is the case. Now let's take a look at this word problem. Okay, Monica and Max Gordon each want to buy a scooter. Monica's already saved $25 and plans to save $5 per week until she can buy the scooter. Max has $16 and plans to save $8 per week. All right, well, let's start by modeling Monica. So Monica is starting with $25. So that's like our y-intercept is at 25. And then she's going, for every x week that goes by, she's going to save $5. So her total amount of money is equal to 5x plus 25. Now Max is starting with $16. And for every x week that goes by, he's saving $8. So his total amount of money, y, is equal to that. So now we're going to estimate. Okay, so let's go up. Let's go up by 2. So that works 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 25 is right here. I'm just graphing Monica. And here's the tricky part. Now that we're going up by 2s, we need to keep that in mind when we're going up by 5s. So we're going up we're going up 1, 2, here's my 5, and over 1, it's here. Okay, so my line is going up that way. Okay, so let's do this one now. We have 2, 4, 6, 8, 10, 12, 14, 16 is here. Now we're going up by 8. So we have 2, 4, 6, 8 over 1/2. Okay, so it's not a perfect graph. But I guess if I were to estimate where they were crossing, I'd pick this point right here, and now I just have to kind of estimate what that is. Well, it looks like they're crossing at about, well, if we're going by 2s, it'll be 4 weeks. Okay, remember we're going by 2, so it looks like they're crossing after 4 weeks. Then I want to see how much money that is. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, and I got about $38. Is that true? I don't know. If we plug it back in, that might not work, because again, graphing isn't the most accurate way of finding the solution. Your solution on your graph might look a little different. So see what you think based on your graph. But this is what I found based on my graph. Okay, so for this one, this is just a little bit more challenging because we have to solve each of these for y. So let's take the first one. We have 2x plus y is equal to negative 4. So to solve for y, I'm going to subtract 2x from both sides. Then I get y is equal to negative 2x minus 4. I'm just going to go ahead and graph that while I'm at it. So I'm crossing the y-axis at negative 4, and then I'm going down 2 over 1. So there's my first line. Now I'm going to go ahead and I am going to solve this second one for y. So I'm going to subtract 5x from both sides. So then I get 3y is equal to a negative 5x minus 6. Divide both sides by 3. And I get y is equal to a negative 5 over 3x minus 2. So I'm going to go ahead and graph that one. I'm going down 2. Then I'm on the y-axis. Then I'm going down 5. 1, 2, 3, 4, 5. And over 3. 1, 2, 3. So that's here. So here is my line. Again, this isn't the most accurate way of graphing. All right, so if we look at where our answer is supposed to be, mine looks like it's at about a negative 2, 1, negative 6, 8. So my graph happened to be way off on this one. Again, this isn't the most accurate method, but it's the one we're learning right now. I want you guys to go ahead and do this one completely on your own. I want you to find your y-intercept, or sorry, find your slope-intercept of the first one, graph the two, and then see what you notice about it. Okay, make sure you make it clear to me what your solution is. Once you're done, you can go ahead and take that quiz.